In today's note, we're going to look at factoring. So factoring is something that should be a review from last year or in grade 10. But we're going to, again, look at it because, again, it helps us change from one form of a quadratic to another. So the first one we're going to look at is when we have x squared plus bx plus c. So the key thing that we're looking for here is 1, the degree is 2, which means the largest exponent is 2. In this case it is, and that is important because that tells us it's quadratic. The second thing that we're going to look for is that there are 3 terms. And if there are 3 terms, then it's what we call a trinomial. So this example below does have 3 terms. And the third thing that we're looking for is that the a value is 1. So again, remember the a value goes in front of the x. If we look at our standard form, it's ax squared plus bx plus c. In this case, we don't have an a value because it's 1. So the steps that we have to go through to factor this is the first one. We're going to draw brackets and fill in the variable. So again, when we factor, we're going to get 2 sets of brackets. Factoring is taking an addition of polynomials to a multiplication of polynomials. So I'm going to have 2 sets of brackets, and I'm going to fill in the variable. So the first term is always going to be whatever my variable is. In this case, it's the x. Next, what I'm going to do is in the x puzzle, so that is this over here. This is considered my x puzzle. Nothing complicated, it's just a way of organizing my information to help me figure out what I'm trying to solve for or what my factors are. But in the x puzzle, the b value goes on the bottom, and we have to look for numbers that add to that, and the c value goes on top, and we're looking for numbers that multiply to that. So again, hopefully this is familiar, but again, we're going to take our b value. So this b value here is going to the bottom, and this c value here is going to the top. And again, the whole goal of this x pattern or this x puzzle is to find 2 numbers that add to c, that multiply to c and add to b. So again, b, they have to add, and c, they have to multiply. So again, we're looking for 2 numbers, not 2 different sets of numbers, just 2 numbers in general that add to b and multiply to c. We want to think about, so the third step, think about what our signs will be. For those 2 numbers. So again, thinking about if I have to multiply to a positive number, right? So if I have a positive, or we'll do a little box. So in terms of multiplying, if I have a positive and a negative, positive and negative, I should remember that when they multiply, those are my options. So 2 positives gives me a positive, 2 negatives give me a positive, 1 of each gives me a negative. So you want to think about that in terms of thinking about what your numbers could be when you're trying to find them. So with your X puzzle, once you find your two numbers, you solve the X puzzle and you place the answers in the brackets. So once you find those two numbers go into the brackets, one in each one. And then finally, we can check our answer by distributing, which is what we did in our last note. By distribution, or expanding, or multiplying, or a box method. So let's start off with an example. So we have x squared plus 4x plus 3. So I'm going to rewrite that out. And I'm going to create my X puzzle. So we talked about this middle number, or the B value, going to the bottom. So 4 goes to the bottom. 3 goes to the top, or that C value goes to the top. And now our goal is to find two numbers that multiply to C, but add to 4. So this one's is kind of straightforward because the two numbers that multiply to 3, well, there's only two of them. It's 3 times 1. And if I do 3 plus 1, that equals 4. 3 times 1 equals 3. So that means that my two numbers are going to be 3 and 1. You may have also seen this as something called the product and sum. So product is multiply, sum is addition. So again, that is another way you could do it. The X puzzle is just more of a way to help you organize your thinking. So we solved our X puzzle. We're going to have two sets of brackets. The variable is X, so that comes first. And then I'm just going to place my two numbers in there. So in this case, I'm going to have plus 3 and plus 1. So that is my equation, and it's factored. So we can see how we've gone from something that was in standard form up here to something that is in factored form down here. So that is the goal of factoring, is to change it from one form to another. Because now that I have it in factored form, I should be able to recognize what information the factored form gives me. Right? Remember, these are my x-intercepts. I have an a value, so it does help me graph it. And then from here, I can take this down to vertex form if I needed to. The last step is just to check our answer. So I'm going to check my answer quickly by I'm going to check my answer quickly if it will let me. So I'm going to check my answer by using the box method. So I'm going to put one bracket on top, x and 3, x and 1 on the other one, and use my box method like we've done in the previous notes. And I'm going to add my like terms. And when I simplify it, I get x squared plus 4x plus 3, which is my original equation. So again, that's just one way to check your answer, just to make sure that it does work. So you should be able to go back to your original answer. The second example that we're going to look at is slightly different because now we have an a value in it. So we're going to be these rules or these steps that we're looking for or looking at now are going to be for when our polynomial has a degree of 2 which means it's quadratic. When there are three terms, so trinomial, when the a value does not equal 1, and finally, when the a value can be common factored. So again, if it can be common factored, that means it can be divided into B and C. So there are only 2 steps to this, but that's because we're kind of referring back to some other steps. So the key thing here is I have an a value now, and this a value is not equal to 1. That's why it's showing up. So I have an a value. So that means in my first step, there's going to be something different. I have to common factor the a value. So I have to common factor the a value, and then the second step is to factor the trinomial as if a equals 1. So basically the steps that we've done in the previous ones. So again, that still means that we have to have our b value, and the b value goes to the bottom. We have our c value, and c value goes to the top. And we're looking for 2 numbers that multiply to c and add to b. So again, the exact same thing as before. The only difference is that we have an a value up front. So let's look at an example. So first what we're going to do is we're going to common factor the 2 out. So the a value is 2. Can 2 be divided into all the other numbers? Well, 2 can be divided into 2. It can be divided into 12, and it can be divided into 10. So that means what I'm going to do is common factor it. And how I common factor it is I take the 2, I put it outside a set of brackets, and then I divide every number in there by 2. So 2x squared divided by 2 is 2, 12x divided by 2 is 6, 10 divided by 2 is 5. So now I've common factored. So let me just write this off to the side just so we can kind of follow along. So this is common factoring. Then the next step of what I'm going to do, I'm going to factor this trinomial or this 3 term just like I would if a is 1, because now that I've factored, it is. So that means I'm going to create my x puzzle. The b value is going to go on the bottom. I'm looking for numbers that add to it. The c value is going on top. I'm looking for numbers that multiply to it. So if I'm looking for the product and sum, or 2 numbers that multiply to this, it is a little bit easy because again, the only 2 numbers that multiply to 5 are 5 and 1, and it does so happen that 5 times 1 equals 5, and 5 plus 1 equals 6. So again, this is an easy one. So now that I've done that, I've solved my x puzzle, I can now factor this trinomial. So the 2 is still going to stay there. I'm going to have now 2 sets of brackets. The variable is going to be first, which is x, and then I'm going to take my 2 answers, the positive 5 and the positive 1, and plug that into the brackets. So this is now my factored form. If I want to check my answer, I can do the same thing with multiplying. I'm going to multiply my two sets of brackets. So x and 5, x and 1, get x squared, 5x, 1x, and 5, which becomes x squared plus 6x plus 5. But we have to keep in mind that that 2 is still out front because I haven't dealt with it yet, so it's still being multiplied. And now I can multiply the 2 through to everything, and we get 2x squared plus 12x plus 10, which is our original answer or original equation. So this does work for this does work. So the 2 times x plus 5 times x plus 1 is the correct factored version of it. So we'll go through a couple practice questions just to make sure that we're comfortable with this. So I'll try to go through one of each where I am common factoring first and one where I'm not. So we'll just start with the first one, x squared minus 5x plus 6. So again, the 6 is going to go on top. The minus 5 is going to go on to the bottom. So now I'm looking for two numbers that add to negative 5 and multiply to positive 6. So I can look at the numbers that multiply to 6. I have 6 times 1. I have 3 times 2, and that's it. So 6 times 1 does equal 5. 3 times 2 does equal 6. But 6 plus 1 equals 7. And 3 plus 2 equals 5. I want negative 5 though. So I have to think, is there a way that I can change any of these numbers to negative? Well, remember we talked about if I am multiplying, and I have a positive, I get a positive or negatives. I can have two negative numbers multiply and get a positive number in the end. So I know that I have the two numbers that add to 5, but I want it to be negative 5. So that means instead of it being positive 3 and positive 2, it's going to be negative 3 and negative 2. Because negative 3 plus negative 2 does equal negative 5. So that happens to be my two answers. So that means in the brackets, I will have x minus 3 and x minus 2 as my factored form. If I go down and look at one here there's a number in front. The a value is not 1, so I have to common factor that out. So I can take the 2 out, I get x squared plus 3x minus 54. So I'm looking for two numbers that multiply to negative 54, and those same two numbers have to add to 3. We'll put a little plus and multiply. So again, we can go through and try to think of what numbers multiply to 54 and add to give us 3. And when we go through that, basically just kind of looking at your multiplication tables, I should get 6 and 9 are the two numbers that can multiply to 54. And if I subtract them, they will give me positive 3. So I have to think about which number has to be negative. Well, in this case, because it's positive 3, that means the 9 should be positive. So when I minus 6, I get a positive number in the end. If it was the other way where the 9 was negative, it would still work to multiply to 54, but I get negative 3 instead, so I just have to switch the signs. So now that I know what my two answers are, I can fill in my two brackets. The first part will be the variable, the second part will be my answers. So x minus 6 and x plus 9. So those are my factored form, and the 2 is still there from when I common factored because I can't get rid of that, otherwise it changes the equation. So again, this should be a review from previous courses, but again, just factoring our two equations or two types of trinomials based on what information we have. Again, the main idea isn't the factoring, it's the idea that we can convert from one form of a quadratic to another form.